You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
We're a team of experienced technologists creating development and testing tools which help teams build cloud-native applications easier, better, faster. CubeShop is backed by the most successful investors in the software industry who see Kubernetes as the foundation for building the software of tomorrow. Insight Partners is an investor in CubeShop and the New Stack.
Hey everyone, today we're talking about testing, cloud-native testing. And it's a topic that I'm really interested in exploring today with Bruno Lopes, who's product lead at CubeShop. Hi, Bruno. How are you?
Nice to meet you, and thanks for having me. I'm doing fine. And you?
I'm awesome. You know, software testing is changing so fast. Everything's changing so fast, as we well know. You know, the complexity that comes with cloud-native technologies is leading to new approaches for testings, and it's affecting the personas, the people who are actually developing their technologies, be they developers, administrators, whoever it might be. So to me, it feels like a little bit of like a renaissance. There's a renaissance in testing. And I'm curious to understand that story. What is that story about testing in Kubernetes and its origins, and how you see it leading to new creativity and new ways that engineers are deploying their technologies?
Definitely. So it's very true that cloud is a very fast moving world, and a lot of technologies are always appearing all the time. And all developers from all areas, like from development, infrastructure, operations, testing, everybody is impacted, right? And what is this Kubernetes that we talk about? It's the way people deploy applications to the cloud also has been changing a lot, especially in the last, let's say, 5 to 10 years. And a lot of companies are adapting to these cloud technologies, but not on all aspects. For example, some people use clouds now to deploy the applications and host them in Kubernetes. So Kubernetes is the place where people host the applications to serve to their own customers. So they adapt that part, which is deploying the applications, but the testing aspect of it sometimes just follows after. So it lags a bit behind. So what it means is that the testing suffers. And sometimes when companies have priorities, when they just want to push out like new features to the product and just want to move fast, and the methodologies and the process they have inside the company didn't move as quickly, sometimes that is a bit neglected. And so that's like what we are seeing. And so Kubernetes is like an amazing framework, it's an amazing platform, allows companies to do a lot of things, but people need to adapt. From everybody in the organization that is involved with the development of new software also needs to adapt as well.
So when did it get started? Like, what do you trace it back to? You say 5 to 10 years ago. Kubernetes emerged in the 2015 or so, 2016, and it changed a lot of how we think about enterprise architectures. Is that the origination, do you think, for how we think about testing Kubernetes? What are some of the things that you reflect upon?
It's the way people think about developing also their applications. So Kubernetes has an orientation to something called microservices. So before that, people built huge applications with a lot of process to test them. Testing was very complicated. It took a lot of time. And then some very intelligent people decided, well, what if we break these applications into small pieces that work very well together, and they are easy to scale, they are easy to test, they are easy to develop, and then they build these architectures to sustain those things. And testing also improved a lot because you can test small pieces of software in an easier way.
Okay, and so the microservices story really emerges here. What did it lead to? What has it led to for engineers?
made more people involved in testing. When you have a big application that is very hard to set up, for example, if you want to run tests, you have to have a dedicated system for it, right? You cannot run on your computer. If let's say you have a big organization, and for your organization to run their product, it's a very, very big thing. Then for you to run it, it's like complex. You cannot just run a test or even experiment with it, right? But if it's just a small piece, you can. It's easy for you to test it on your own computer. It's easy also to spin up in a new, for example, cluster. Makes it easier for everybody to test it. And now what that does is changes the roles of people. I'm not saying that it was only because of microservices that everybody's testing more, but it's certainly a factor. So when you remove obstacles to testing, you make it more accessible to everybody, right? So people feel more comfortable in starting testing, and the quality of the product, of course, improves.
What objects do you think of in particular that were removed?
So the first one is the automation side of it. So, for example, to automate those big processes for big applications, the more complex something is to automate, the less people will do it because it's hard, and they will always do an analysis of cost and benefit. And if the cost is like bigger than the benefit, people usually don't tend to do it. So when you remove the cost and the value is also perceived as being higher, we have people doing it more. So one is automation. The other one is the complexity. So when you have very technical processes for somebody to run these things, you make it only available for the more technical people. So the less technical people will not go into that, right? They'll say, okay, I'm not sure how this works. I'm not going to go that far. When you make it less complex and less technical, everybody will do it more.
So the experience has improved.
Yes, a lot.
How do you see the experience improving for example for particular projects, for instance?
One example and one way we can observe this improvement in testing is the release cycles of teams. It's a common characteristic of successful businesses that they are fast. They are fast in delivery. So they iterate fast, they have short release cycles, and they are always like shipping stuff. In these release cycles, if you don't want just them to be fast, you also want them to have quality. For you to make sure they have quality, you need to test it, right? You need to test what you just developed. So you don't spend so much time testing, or you make testing like very easy and affordable. So we can all see that most companies are very fast and they're implementing like a lot of automation tools around this testing. So it's observable that it became easier on the cloud, just looking at their release cycles.
We've seen so much happen in the cloud native space. What are you seeing as trends then in Kubernetes testing?
The biggest trend is, so we have in the last years, people are adopting it, right? And they are learning how to exactly work with Kubernetes. You have companies that are running for a long time, and they use VMs in the past, or they use other technologies, and now they look at Kubernetes and thought, okay, this is great, right? Let's use it. So what they do is like they start adopting it, and they start changing their applications to live inside Kubernetes. So what we see there is, okay, they change that part of deploying the applications and making them available to their customers. And as I said before, the testing part, they don't focus on that as fast, right? Or they don't have that know-how on how to do it. So the trends we see is always, they start with Kubernetes, they deploy the applications there, but then they don't test the applications where they live. So they usually they have the old ways of testing. And the trends we are seeing is that they are adopting new methods of running these tests. They are leveraging more and more Kubernetes. They are automating things that way more. They are running more things on the cloud, things that can scale up and down as easily. And they are spending way less time on things that they shouldn't care about, right? You shouldn't care about like the automation or to like plug all the systems. You just want your application to work and to be delivered fast to your customers, right? Everything works fine. Everything is really fast, and that's the main goal. And the trend we are seeing is that there's a lot of technologies on the ecosystem that are being developed with this in mind. Is how can we make the lives of developers and testers easier, right? How can we remove jobs from their plate?
Testing has led to better approaches in terms of the developer experience. One of the great issues that we have in the cloud and on-premise and everywhere is configuration. And configuration errors do lead to terrible outcomes. And so what's the role of testing you're seeing emerging with helping reduce these configuration errors?
That allows you to see that, let's say you have a configuration issue, right? The problem is sometimes you don't get visibility on it. If you have the configuration of your application, it's like a bunch of different values, different files, different ways that you can run your application. For you to detect that might not be, easy for a human just to read the files. Is not detected soon enough. So if you have automated testing to catch those things before you release to your customers, is when you catch these problems. And so that's the biggest challenge, is the complexity of automation. There's always complexity around automating the test that your team creates, right? Because the environments where they run, they are different. Between each test, there are different requirements or different things that they are testing. So that's like the first part. The second part is it's hard to integrate testing tools because most testing tools were not made with Kubernetes in mind or like to run in the cloud. They are made with a specific purpose, which is like testing their specific part of the application. For example, if it's a tool for API testing, that tool is very good at API testing, but running in the cloud or running Kubernetes is not their main concern, right? The same thing with Cypress for front-end tests or like any tool that tests different aspects of the application. Like most of them are not made for this, right? So that's like one of the biggest challenges.
I would like to talk a little bit about how different people on the teams are impacted by testing. So I want to talk through, people who are developers, who are platform engineers, who are SREs, who are even the vice president or the CTO. So let's start with the developers. What are some of the pain points? There's YAML files, there's overlays, there's Helm charts, and how all those things relate to each other. How do developers avoid, breaking, these environments?
That's a very good question. And, most companies ask that, which is very important. So everybody that contributes to the success of the application wants to know that it runs correctly, right? In the end, a test or a testing process is the process of verifying if the application behaves as you expected it to, right? So you have some expectations of how it behaves. You create a test to see if that expectations matches what is the reality. So different roles in the company, they contribute in different ways to the application, right? So the SRE just wants to make sure that things are running as they should. The developers want to see if the features that they just built, do the functionality that they were asked to implement, and testers also focus on that. So depending of organizations, not all of organizations have the same roles or the same structure or the same processes. So it changes company to company. Just like to make that aware, and we know that, right? Each company is different, and so all of them have a stake in testing, right? They want to test something, but however, based on their roles, they want to see different things. So the more we make that testing process less complex or less or more easy to understand, the better for the company, right? as you mentioned, like the director, the CEO, somebody just wants to see basically, okay, is the application is running like as intended, like all the tests are passing. So that's like very important to them. For SREs, maybe they just want to see like if the availability up and down, right? The developers want to see a specific feature. So yeah, the requirements for testing changes between the roles.
So when it comes to the platform engineer, one of the things you're really interested in is, achieving that desired state, right? So I'm curious about the templates and the guardrails that platform engineers can put into place to quickly achieve that desired state. How do they get started?
Exactly. So the guardrail usually is don't ship anything to production that you haven't tested. So that's like one rule number one. Number two is perhaps have an environment that very closely resembles production, where you can run all of your tests. So you can deploy all of your applications. You should deploy data that's very similar to what you see in production, and then run like a lot of tests, right, to see if that environment is very close to production and the test pass, right. It's very likely that production won't fail as well, right, because they are similar. That said, the environments are never 100% similar, right? They are really just different things that you try to make one mimic the other. So it's not 100% fail-proof, but it's a good measure of knowing, like being more confident on your deployments. And make it like very fast. So you shouldn't make your developer team wait for let's say a manual QA that's going to test the application manually to see if everything's all right before deploying. You should deploy as soon as you can, as fast as you can, and without like everything should be automated, and you should deploy without waiting like for manual tests.
So as deployments increase, there's always concerns about what might slow it down. Testing, I expect, in the inverse can be seen as speeding it up. But I'm curious about GitOps and the adoption of GitOps, for instance, among platform engineering teams. How does testing affect that?
So it's like how GitOps affected testing. Maybe it's like more the other way around. So GitOps is for our watchers that are not aware, is the process of storing the desired state in your Git repo in a version control way. So instead of, let's say, you want to deploy application and you make a manual action, you describe on your Git repo that you want something to run, and then something will make it be on that desired state as you have on GitHub. So in testing is you describe how you want your applications to be tested in a declarative way, and then you have some other tools that make a conciliation of what you want the things to run, and they will make it so. And the really good way of how this works is that the code is also stored in Git, right? So if you also do the same way that you have declared like what your code is, and you also do the same things for your tests, it's very easy for you to make a cluster that behaves the way you want it to. And it's very easy to catch bugs and easy to see what you did wrong. Because if you make a change that makes for example, your testing process don't work so well, that's in Git, right? That's version control. So you can see exactly what was the change that may have broken your system. So that definitely impacted testing. We see more and more people just wanting to do everything on GitOps because it's very easy to debug, it's very easy to implement. So yeah.
Let's move on to SREs. They need to be able to quickly inspect and troubleshoot their cluster configurations. They need to understand, if things go wrong, why they went wrong, how they went wrong. So comparing configurations becomes really important. I'm curious about this and how testing helps in that process of comparing configurations.
Exactly. So SRE team is a team that needs to respond very quickly when something is done, and they want to basically be fast at debugging, as you mentioned, right? The longer they spend time seeing what was the issue, it means like there's more downtime to their customers, right? So that's very interesting. And probably like the people that want to run tests in Kubernetes the most are SREs, because they really need to test live applications. They really need to test it where the applications live, and sometimes, especially in critical systems, the applications cannot be exposed to the internet, for example, right? So if you run your tests outside of Kubernetes and you are trying to test it, things that are running inside, right? You need to expose that to the outside, and that probably won't work for all companies based on their restrictions. So especially for SREs, it's important that they run tests inside Kubernetes and they have like a lot of observability. What's the status of their applications.
And finally, let's move on to the vice president, or that CTO, who is really responsible for the business. And they have to be thinking about delivery. They have to thinking about how that application drives their business, and they can't get dragged down by intricacies, and and the issues that come with configuration management and workflows. What do you say to them about testing?
Well, a good CTO will understand that testing is an important aspect, right? They should spend some time on it. So on the short term, sometimes testing is seen as, okay, it's a waste of time, right? But if you catch a bug later on that you don't know what it is and it impacted your customers, the cost to you is going to be bigger than if you spend some time testing it and you catch it sooner, right? So for CTOs, it's especially important to have observability just around the testing processes. Is the team testing like well when they are shipping? Like the biggest advice I could give them would see just observe the process, and then have a way of seeing like what are the test results, like if the things are passing, failing. So if you can just see that happening, that will be the best way to improve the quality of your product.
Bruno, before we go, tell us a little bit about CubeShop.
So CubeShop is a Kubernetes company incubator. So they have 6 different projects that they created in the Kubernetes area. I'm the product leader of one of the best product. Well, I'm biased saying that because I'm the leader of this one. But this one is TestCube. It's a Kubernetes native testing framework. So that's why we are talking about testing, and I know a lot about testing by talking with our users, with a lot of QA people. So we really want to make testing easy in Kubernetes. We want to solve all of the biggest challenges of testing, and so that's the main goal of TestCube. So CubeShop really wants to improve the space around Kubernetes, and TestCube wants to improve the testing aspect of the companies that have Kubernetes clusters. They want to test it. They want to to develop fast. So we want to remove all of those challenges for them.
Bruno, thank you so much for your time. I've enjoyed learning a bit more
Thanks
about
so much.
testing.
It was a pleasure being here.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.